Sorry, I just wanted to record this for people who aren't here. Hopefully that's working. We'll see. Okay, so I've got a directions here. We're going to write an equation of each line in slope-intercept form. So I want my answer to look like the very first form of the equation. To write an equation in slope-intercept form, I need the slope, obviously. And the intercept represents that number where it crosses the y-axis. So just for a quick visual, you don't need to write this down. The slope-intercept form, I need to know what the slope is, and I need to know what this point is right here where it crosses the y-axis. And just a little background on the y-intercept. Every single y-intercept has the exact same x-coordinate. So what is the x-coordinate of a point if it doesn't move right or left at all? It's always going to be 0. So if I do have a point that has an x-coordinate of 0, then I know that's the y-intercept. I look at this point. Does that point have a x-coordinate of 0? No. What's the x-coordinate? What's the x-coordinate of the point they gave me? 2. Okay, that is not the y-intercept. So this point right here isn't the y-intercept. I know what the slope is. Great. I could fill in what m is, but I don't know what b is. I don't know what that y-intercept is because this is not a point that's got an x-coordinate of 0. So the point 2, 1, this is not going to be a scale or anything, but the point 2, 1 is like somewhere over here. That point doesn't represent the y-intercept at all. So I need to have a new way of trying to figure out, well, what is that equation going to be in slope-intercept form? Because I don't have the y-intercept from that point. Well, that's where our good friend point slope comes in. You can kind of hear it in the name, point slope. What do you think you need to write an equation in point slope form? A point and a slope. If we have those two things, we can write it into point slope form. So let's take a look at what that looks like. And this is kind of a little typo. I forgot to put the equals. This is a slope of -2, and then it's a point of 2, 1. Now to put it into point slope form, the y1 and the x1 represent the coordinates of the point. So I'm going to go y minus 1 equals -2, x minus the x coordinate, which is 2. So here's my point slope form, inserting the slope for m, and then the point 2, 1 in for x and y. But is that in slope-intercept form yet? Is that in y equals mx plus b form? Not quite. We just have a little bit of algebra to do. It's very basic algebra. You all know how to do it. First thing you do is you take and you distribute. -2. Y minus 1 equals -2x plus 4. Getting closer. Now we just have the y to get alone. Well, y is being subtracted by 1, so we'll add 1 over. How's that looking now? Now we're back into slope-intercept form. So slope-intercept form for number 1 is going to be y equals -2x plus 5. So that satisfies a slope of -2. And if that y-intercept starts at 5, it's going to go down at a slope of -2. It is going to hit that point 2, 1. So that's what we are taking a look at. Biggest mistake I see is we see the point, and then we just use that point as the y-intercept every time. Well, that point isn't always going to be the y-intercept unless it has an x-coordinate of 0, which could happen. But if we don't have the actual y-intercept, we've got to start in point slope form first, then we go back to slope-intercept. Problem 4, we'll take a look at that one next. It says, write in point slope form an equation of a line through each pair of points. So if I look at that number 4 there, let me just mark this. This one up here was number 1. This one here is number 4. I didn't really give you guys a lot of room to work, huh? Sorry about that. You'll have to use the margins or else the back of your sheet will be plenty of room. I need to write an equation in point slope form using these 2 points. Well, I do have this point, I could use either one of these for point slope, but I need to know what the slope is. So I got a little work to do here first. I do need to figure out the slope is. So I'm going to go m equals, subtract my y's. So I'm going to start with 9, subtract 3. Then I'm going to go and subtract my x's. One thing you got to make sure you do, if you start with 9, you got to start with 2 when you subtract your x's. Or else you get the opposite slope every time. You can put 2 minus a negative, or I just change it to 2 plus 2 because minusing a negative is just going to be adding. 6/4. Slope's going to be 3/2. So now I've got my slope. I've got my point. Do I have enough to write it in point slope form? Sure do. Looking at the 2 points, you can choose either one. I always just choose the one that's got smaller numbers, so any calculations I need to make, I can make those a little easier. So I'm going to take y minus 3 equals, slope is 3/2, x, and then it's going to be minus a negative 2. Just change that to plus, x plus 2. So there would be my point slope form. If we wanted to, we could change it into slope-intercept form. We could distribute that 3/2. Okay, 3/2 x plus 6/2, which is 3. Add that 3 over, we're going to be back into slope-intercept form. But it does say to leave it in point slope, so there's my final answer. So how's that going? Is that dusting off some of the old cobwebs, Algebra 1? So it's important to have those 4 forms, so when you're presented, okay, I need an equation in slope-intercept, or I need it in point slope. So whatever form it needs to be in, that you kind of have the outline of which one they're talking about. The slope-intercept, point slope, you kind of get things mixed up. If you have those all in one place, it's nice. And I think in section 2.4, there's a little table in the notes where you have a spot to put all 4 of those, or at least 3 of them: slope-intercept, point slope, and then standard. All right, we'll finish up talking about standard. I'm actually going to throw in, we'll do number 8 because that one's pretty easy to do too. Standard form. Putting an equation into standard form, the big thing that you'll notice is x and y are now both going to be on the same side of the equal sign. And then a, b, and c have to be specific numbers. They have to be integers. Must be integers. Or in other words, you can have no fractions or decimals. So to be in standard form, there is no fractions or decimals. There's all just positive, negative whole numbers. So a, b, and c, we must make into integers. And you can see on each of these problems here, we've got our y and x variable on opposite sides of the equal sign. We can rearrange things, move things around. But we've also got some fractions, decimals, fractions that we need to convert back into integers. A pretty easy way we can do this, we can use multiplication to change a fraction back to a whole number or an integer. With fractions, what you're looking at is you're looking for the least common denominator of all or any of your fractions in there. So think of it about like if you were going to add them together. So you have a 3/2, 1/4. If you're going to try to make those a common denominator, what would you use as a common denominator? You're going to add 3/2 and 1/4. What's their common denominator? 4. Oh, 4. So you're looking at what is that least common denominator. When you're multiplying fractions by their denominator, by a least common multiple of their denominator, you're going to be able to clear the denominators of your fractions. We're going to show that right now. So now that you found that the LCM is 4, you can take and multiply your whole equation by 4. You may be wondering, well, why can you do that? Well, the properties of equations say as long as you multiply both sides or divide both sides or add both sides by the exact same thing, your equation is still going to stay equal. So we're going to take 4, hand it out. We're going to get a 4y. Then equals, now we start multiplying. Don't get too freaked out about fractions. 4 is actually a fraction. You can just think of it as 4 over 1. So you multiply your numerators, 4 times 3, 12. Your denominator is going to be 1 times 2, so you're going to have 12 over 2. And what's 12 divided by 2? 6x. So there's going to be our 3 halves multiplied by 4 is 12 over 2, which gives us 6. 1/4 times 4. So multiply your numerators. 4 times 1 is 4. Remember, 4 is considered a fraction. 4 over 1. 1 times 4 is 4. So 4/4 is 1. So I'm going to be left with 4y equals 6x minus 1. And how am I doing? Do I have any fractions or decimals left? Nothing. So now I'm good to go. I'm in this class now. Okay. You can sit right there. And then right here, the only thing left to do is I have to get x and y on the same side. So I'm going to take negative 6x, bump it over. I'm kind of running out of space. Let me kind of put it over here. Negative 6x plus 4y is going to equal negative 1. And there we go. My preference is I like to put the negative, or I like to put the x first, then the y. It doesn't matter. If you put 4y minus 6x equals negative 1, you're okay. So that's where we're going to be for number 7. 8, you got some decimals. You think about this decimal. This would be 4.2 or 4 and 2/10, 1 and 8/10. So both of these decimals are dealing with tenths. Tenths. What do you think you're going to need to multiply by to get rid of tenths as a denominator? By what? 10. Get rid of tenths, multiply by 10. So then multiply everything by 10. This becomes 10y. This becomes 42x. This becomes 18. Get rid of those decimals. From there, I think you guys can handle it. Just get that 42x bumped over. Boom. You could multiply by 5. That would work too. So you might see a little variation different on the answer key. That's okay. As long as you're in the same ratio as the answer, you're going to be okay. The last thing to look at with standard form is how to graph it. And they are pretty easy to graph because you can quickly find their intercepts. We've already talked about the y-intercept. So who remembers when you have a y-intercept, what is the x-coordinate of a y-intercept always going to be? What is that x-coordinate always going to be? 0. So 0 something is going to always be your y-intercept. Now think about the x-intercept. So when that line goes down, it crosses the x-axis. What's the y-coordinate always be? You don't have to know where it crosses, but what's the y-coordinate always going to be on the x-axis? 0. So an x-intercept is going to be at the point x, 0. This gives us a little clue about where these intercepts are going to be. It's kind of like we know half of this point now. So if we want to find the x-intercept of a standard form equation or even a slope-intercept, we got to find out what is the value of what is the value of x when y is 0 to find that x-intercept. So we see a line here. We don't know. We know it eventually crosses the x-axis. We don't know where, but we do know that the y-coordinate is going to be 0 at that point. So to find the x-intercept, we are going to keep our variable x. We're going to put a 0 in for y. And look at that equation. You guys have enough information to solve this equation? 3 times 0, what's that going to be? 0, x is equal to -4. Now, I don't want you putting x is equal to -4. That's not the intercept. That's just the x-coordinate. The intercept then is -4, 0. There's your x-intercept. You don't know exactly just looking at the equation right away, but once you put a 0 in for the y, that's going to get you half of that solution. Then you got to go and find the other half, the x-coordinate. So there's your x-intercept. Now we got to find the y-intercept. To find the y-intercept, we're going to put a 0 in for the x, and then we got to find out what the y is. So I'm going to put a 0 in for x. Ultimately, that's just going to make that x disappear. So you're going to have 3y equals -4. Y is going to equal -4/3. Not my answer yet. X is 0. Y is -4/3. There would be my y-intercept. So for both intercepts, we know that a line is going to cross the x and y axis, and we know that wherever they cross, either the x-coordinate or the y-coordinate is going to be 0. So we have to use that as a clue, then we can find out those intercepts. Then to graph it, you can graph it really easily. If you graph those 2 points, boom, draw your line, you've got your graph. So I'll let you do that part on your own. Okay? That's enough. That's enough of your time. So the rest of the time then is yours to work on 2.4 if you need to. And then any questions from anything in the past. But I'll kind of be coming around to answer any questions and clear up anything if you have questions about anything in the past. But the rest of the time is yours. I'm going to leave this up here. I know it's kind of messy. I'll leave that up there if you need some time to copy the rest of it down. Yeah, okay. Yeah.
But then we were like, oh, we don't do that. So I switched off our team to finish that.
Okay.
And then we just realized after this game on Monday that we read it.
St. Paul?
Yeah, what?
Oh, yeah, because they're NCAA. Yeah.
Yeah. So now I switched to here, so I went from